Now we will begin part 2, the panel discussion. This session will be conducted in Japanese.
Please allow me to introduce our panelists from the left side of the stage. Professor Ai Hisano, Associate Professor of the Interfaculty Initiative in Information Studies, and Professor Yuji Ikegaya, Professor at Graduate School of Pharmaceutical Sciences, Professor Kenichi Ohki, Professor of Graduate School of Medicine, International Research Center for Neurointelligence, Professor Hitoshi Tabata, Professor of Graduate School of Engineering, Professor Eiji Saitoh, Professor at the Graduate School of Engineering, and Professor Tatsuya Harada, Professor at the Research Center for Advanced Science and Technology. And the moderator is Professor Masami Hagiya, Director of the Institute for AI and Beyond. Now I hand over to you, Professor Hagiya. Thank you very much. This symposium, in the very last part of the symposium, panel discussion is usually conducted in Japanese. And this time too, we have 3 new academic fields emerged. And in Japanese, we would like to have a very frank and informal discussion in the panel discussion. This is my intent. But on the other hand, so far, we have heard presentations from the 3 fields, and as you understood, there is a huge diversity. And in the earlier session, we talked about diversity as well. So depending on the session, some session went wild, if I may say so. So in this panel discussion, these 3 new academic fields, I would like to have some format for our discussion. So we are going to follow a certain format in this discussion to give you more explanation regarding the 3 fields. This shows the Beyond AI introduction, shows you the same picture. This is about mid and long-term research segments, leaders and sub-leaders, as you can see the pictures. And here, leaders are now assembled on the stage. This is the flow of the discussion today. So we have only 40 minutes. So we have to contain our discussion in this time frame. So it is minute by minute precision, but I don't think this will be observed. So this is the last panel, last session, and I was told that we can go a little bit overboard. So I hope we will be able to have a very active discussion. Now, to start, 3 new academic fields. Apart from those 3, I want to invite another speaker. You can see Professor Harada's picture here. And he has been working at the core of AI studies. I want to ask Professor Harada to talk about Beyond AI activities. And then for each of the 3 academic fields, new fields, the definition of the fields has to be provided in the first place. And based on that, I would like to have comments from each leader of the fields, and then have a question and answer session with the audience. This is how I would like to proceed with the panel discussion today. Now I hand over to Professor Harada. Thank you for the kind introduction. I am Harada. The advancement of AI itself, I am leading this project. In this project, Sugiyama Sensei, and this is co-proposed with Professor Sugiyama as well. As you know well, LLM and other generative AI, the fundamental foundational models, and what kind of data to be fed in, depending on task given, we can expect quite good predictive models. However, in reality, if we are to use this technology in practical use in each domain, the high quality training data has to be collected in order to retrain foundational models. That is the current status. And this is what we proposed 6 years ago. And in this way, in each domain, high quality data has to be collected. And also there are rare and unknown events that have to be addressed. However, this is the challenge we are facing, although Gen AI is becoming very, very popular. Therefore, in order to disseminate the foundational models in the society, we have to go over these problems. In order to solve these problems, we like to build automatic learning of highly accurate prediction models from limited supervised data. There are so many topics we are handling, and mainly speaking, we have 4 topics. The weekly supervised learning, transfer learning, domain adaptation, non-Euclidean machine learning. With the limited time available today, I want to focus on weekly supervised learning. Now, weekly supervised learning, what is it? Professor Sugiyama's group is leading this part of our project. And the image understanding, voice speech recognition, machine translation, you are using this technology. However, we need to use weekly supervised learning. This is the supervised learning. However, in some application areas, training data is not readily available. For example, medical care, you have to go to doctors to provide an annotation. However, doctors are very busy, so it is not very practical. And also natural disasters, materials, and privacy. Due to these issues, it is impossible to collect supervised data. In order to overcome this problem, Professor Sugiyama's team wants to make use of weekly supervised data, which is easily obtainable, in order to obtain high-quality data. Now, one example is data from positive unlabeled classification. To be more specific, the click prediction of the web data is easy example. The users are interested in something and they click link, and this is a positive data, if you will. On the other hand, the link which has not been clicked, and that was not clicked because user was not interested in, or there were too many clicks and therefore they didn't look into each click. So we can't make a judgment. We can distinguish. So clicked link is a positive data and we can use. However, unclicked data is not unlabeled data. So this is how we treat and make a distinction. So with this unsupervised classification data, we can get the high quality data. So weekly supervised classification problem wide ranging. For example, if data is given only confidence, or the similarity and dissimilarity of data is only provided, and also in each problem should not be solved separately. So weekly supervised classification needs to be solved with theory and algorithm developed by Professor Sugiyama's team. That is the biggest result, achievement. And this can be applied to the various applications. And it is published in English, machine learning from weak supervision, as you can see. And also that can be applied to reinforcement learning, imitation learning, large-scale pre-trained model as well. Let me talk about domain adaptation, which is led by my team. So domain adaptation, what is it? To start with, in terms of motivation, we have the same motivation. In real world, we want to reduce cost of collecting supervised data as much as possible in order to improve the quality of data. More specifically, we have a source domain where we can get a lot of labeled data. However, there is a target domain where label data is scarce. So we want to transfer knowledge from the source domain to target domain. So in terms of simulation, the autonomous driving and robot data can be collected, and that can be applied to the real world. If that functions, that's good. However, if we do that, we found that this is not successful, and there is a difference between simulation and real world. That is what we call the domain gap. And the field of machine learning that studies methods for constructing predictors that eliminate the domain gap and achieve high performance in the target domain is called domain adaptation. So we want AI that keeps functioning reliably even when the environment changes. So on various conditions, problem setting differs. The availability of label, could we access source data, model parameters, and also label space issues and others. So this is too much of a detail, so let me skip explanation. But the problem of domain adaptation was solved separately using a separate algorithm and theories. However, we have to establish theory and algorithm for general solution in domain adaptation. Our theoretical background could be diluted if we don't do that. Therefore, we want to establish a theory algorithm, which is common. I have so many things to tell you, but let me summarize. The AI advancement is our project, and we want to establish a learning theory and algorithm for prediction models utilizing weak supervised data. I talked about knowledge transfer theory and algorithm as well. And going forward, by integrating continuous learning with theories of weakly supervised learning and domain adaptation, we will realize intelligent systems that autonomously become smarter in the real-world environment. And we want to continue this study going forward. Thank you very much.
Thank you very much. We're only accepting questions for participants at the venue in person, but are there any questions? If not, thank you very much. In Beyond AI, as was introduced, we've been engaged in AI mainstream research, so I hope that all of you will take interest in our activities. Next, regarding the 3 new academic research fields, let us engage in some discussion. First of all, the physics of intelligence. For each academic area, myself and the professors cooperated in order to come up with a short text of approximately 1 paragraph. First of all, regarding the intellectual physics, to pursue law of physics that control the intelligence, and by implementing through physical device and physical law area that pursues new knowledge, spin wave, spin glass, quantum fingerprinting. These physical phenomena are utilized in physical computing, and this is the first step. In the experimental physics of intelligence, the manifestation process of intelligence is captured through physical law such as symmetry and realizes through physical device the complexity and elucidate through AI the phenomenon. In the first session, there was an explanation on symmetry, and I wish Professor Saitoh to explain about that later. These are some of the results delivered through Beyond AI. Quantum fingerprinting, decoding, research on this topic, first of all, and using quantum fingerprinting, recognizing numbers, that kind of research was explained. Further, Professor Tabata talked about fluctuation, yuragi, and reservoir calculation through spin glass was an outcome of Professor Tabata, and an application of yuragi is gas sensor. Now, Professor Saitoh and Professor Tabata, could you add to that?
This phrase are very, very elaborately done. What I wanted to do really is beyond AI, we would like to understand intelligence with numbers or quote equation. I think many people have thought about that with that motivation. But naturally, if we have such an equation formula to describe this, it is possible to use other formulas. Historically speaking, physics have been doing this in many ways. And more recently, the Nobel Prize recently give award to the first pioneering physicist. In the case of University of Tokyo too, for example, the complexity was one of the viewpoints. Now, what is different in our case from the past research? Using the advancement of physics of last few years, we would like to create a new area of AI studies. In my area, we use gauge theory to describe intelligence, and Professor Mogi and I had a 1 hour conversation, but we couldn't come to a conclusion in terms of how we can best communicate that to general public. But someday in the future, I hope that people will understand, and I hope we'll be able to produce a language to explain this. The quantum physics has been produced, and thanks to that, it took a lot of time for quantum physics to come up with a language so that people in the world can understand what it is. So by using a formula, and there, to some extent, we can do it with geology. And however, a neural network is the first step. And to what are we going to use? Naturally, by using simple systems, maybe we can do something similar to what AI can do. Therefore, we don't have to use gigantic networks. Therefore, we often emphasize importance of universality. That is very important. As long as we can find a universality, everything that follows would be easier according to our history. So that can change the current state of AI. What is behind this? The control of fluctuation, that is a concept behind that. So in that sense, Professor Tabata's Yuragi electronic device is a common feature between us. So where could we see the advancement in the yuragi? And that is about Maxwell's demon. So I think we could mention Maxwell's demon in our presentation too. So 5 years from now, with what language this concept will prevail in the future? What language? Thank you.
Thank you. Professor Tabata? Thank you very much. Bioengineer major and electrical engineering are my major fields. So semiconductor electronic devices to AI. I look at how these devices and technology can contribute to AI. And this time, one of the topics we discussed is Professor Copfield, and that was mentioned by Professor Ohki. Half a century ago, spin glass physical concept was suggested, and neuron information processing, the simple equation was described. And this is a great model, and it was quite a revelation. And 2 years ago in 2025, it led to the Nobel Physics Award. So I think it was very much to the point. A simple equation that describes the truth, and from something very simple, it expands into ideas and various diverse application. And I was once again reminded of that importance. So I personally wish to, just by using one coefficient, we may be able to, as I said, it's like a spiral, helical structure of scientific evolution. So Coffield was looking at the same thing half a century ago. But depending on the generation, there has been evolution in the technological understanding. And in the next phase, we may be able to use and implement that concept and model. And I hope to contribute to that phase. Spin glass is important as a concept, and it's also important as a matter that realizes fluctuation. So it's something real. And we happily were successful in discovering that. So we truly hope that that could lead to social implementation. That's the concept. And I wanted to give that message.
Thank you very much. Let's go on to the next field, brain AI fusion. And in this way, we put together that definition here. And this research field aims to fuse the brain with AI to create new forms of intelligence through research integrating brain-specific information processing mechanisms into AI to create brain-inspired AI, and research expanding brain function through brain AI fusion, research integrating iPS cell-derived brain organoids with AI, research integrating human neurodiversity with AI. So we have successfully achieved the fusion of the brain and AI, thus created a new academic field. I think there are many ways to fuse brain and AI, but we are promoting the study in the direction of brain AI fusion. There are many achievements already. In the second session today, the leaders and professors have explained. Professor Ohki explained the first bullet point, that is through analysis of neural fluctuations and their incorporation into AI, vulnerability of adversarial attacks was reduced. And Professor Ikeuchi talked about the connectoid research results, although it was not presented, but in terms of beyond AI, bio-neuron function and future international symposium was held. I think this was very important achievement. And Professor Ikegaya talked about the distinction between English and Spanish by RAT, and also, as you can see, heart rate and breathing feedback related research is going on. And also Professor Nagai talked about visualization of cognitive personality using robots. Now, Professor Ohki and Professor Ikegaya, could you give a supplementary comment?
Then let me go first. In session 1, we took up the physics of intelligence, and I came here looking forward to listening to the presentations. And we did not have any prep meeting, but Professor Saitoh and Professor Tabata both talked about use of fluctuation in AI. And I'm doing a similar research, so I found many similarities, so I found those presentations extremely interesting. In my presentation, at the beginning, I talked about history, and so far, AI has learned from the brain network structural aspect. Much of what it has learned from the brain is network structure, but by taking in noise or fluctuation and yuragi, more flexible and creative AI may be developed. Thank you.
Brain AI fusion, as it says. So the fusion of AI and the brain, if some people, people in general hear this, maybe they would think of this as an innovation, bringing together neuroscience and AI. So neuroscience-inspired new kind of AI can be produced. However, what we are doing is more the low order. What would happen if we connect AI and brain? And at the end of the day, by using AI, the brain information can be read. That is a big important point. Even if we log activity of brain, Fourier conversion and classical mathematics will lose a lot of information, and then we can't decode anything. However, AI can produce a raw data for us, and distinction between Spanish and English is now possible, and that result is a very big achievement. So, as I said in my presentation earlier, if we apply this to human beings, what happened? So perhaps the biggest concern would be the ethical issue. So maybe humanity would be collapsing, and also this is going to be a betrayal to the God, and there are many people who would hate that kind of things from happening. Therefore, technology can deprive people of zest for living, and also human beings prioritize well-being, and I want to put it at the highest level of priority.
Thank you. On brain AI fusion, if there are questions from the floor, please raise your hand. Yes, please go ahead. It's not just about brain, but I have a question on physics. Thank you very much for the exciting presentations. I was listening carefully, feeling very excited. But as I listened to the presentations, it seemed like information processing was the key. And many of what you said was regarding the pursuit of information processing. But on the other hand, generative AI today is about high-dimensional data being collected en masse, and that is the key to changing performance. That's one perspective. So enormous data has to be collected, and from such requirement perspective, through physics, intelligence equation in the brain system, if we can solve the bottleneck of collection of enormous data, then is there an approach in the extension of the methodology currently applied? If you could share with us your thoughts. Thank you. In terms of capability, there's a more complex challenge. It's not just task that is given being done perfectly. Then in the case of quiet or tacit AI, they would be more successful. When AI and humans compete, humans cannot defeat AI. It's the same thing. And rather than upgrading processing, cognition or will, if they are drawn into equation, what kind of equation will it be? It's not being trained. So if a will or cognition is created spontaneously, what kind of equation would be applied? If it's training, it's a result of training by enormous data versus something spontaneous. Then if we have both, I think it would be great.
So from the brain side, anything? Yes. We have to have a different type of innovation, in my view. AlphaGo typically is exceeding human power, and amount of training is so different. Have several millions of trials are necessary in order to increase AI's capability. However, in the case of humans, only several thousands is okay. Therefore, mechanism of behavior is completely different. Therefore, if we base a technology on human neural network, I think it will be insufficient. However, perhaps from the completely different perspective, neuroactivity innovation would emerge.
Thank you, Professor Hanada. Thank you very much. Originally, like Kanetsu-san, computer vision was being done and we were collecting enormous data, but in computer vision, using internet data to do trading, that was fine in itself, but the data on the internet, it's only information people think it's interesting in the real world. In other words, all the data goes through the human filter. So there's enormous data, but we're just circulating finite information. When we live in the real world, information is infinite. But in the midst of infinite information, how do we pick up useful information? And I think that is the essential problem. In other words, we only think in three-dimensional, but if we think about the fourth dimension, then we may be able to discover the good information, and that's one of the origins of intellect. So from the infinite dormant information, how do we pick up? If you have any good clues from physics or brain science, then we would be most appreciative of such findings. Thank you.
Thank you very much. At this point in time, would you like to say something as a response? Yes, I totally agree. Basically speaking, earlier, the models that was presented earlier, that was from the, in terms of the predictive encoding, the human beings do not use filters, and the human have a will to decide what to look at. However, human beings do not have a strong will. If we give a strong will to AI or system, the best combination is strong will and all the knowledge. So maybe at the end of the day, this is a power of representation, and this is closer to existing parameter domain.
Thank you very much. Let's go to the next discussion point. The final point is critical AI studies. Based upon LC and AI ethics, the existing human perspective, social perspective, and value order is once again questioned in this academic field. In this field, AI's creativity, how intellect ought to be, how AI changes the human perspective is the focus in order to make and naturalize certain values. Ethics is not reduced to a checklist for compliance through embedding questions which are not sufficiently captured in ethical guidelines and governance rule-making into the design and development of technology to come up with an intellectual framework or fundamentally rethinking the nature of AI itself. So this is a text created mainly by Professor Hisano. Would you like to add to that? Thank you very much. I prepared this additional slide. This is almost the same as what I explained in session 3. So I will not go into the details of the BAI Global Forum activities, but to date, we have been thinking how we can develop critical AI studies, and that has been one of the core elements of our activities. And there are 3 pillars: global joint research, outreach, and education. Next, could we come to the next slide? And so far, we have been focusing on how we think about critical AI studies and how we establish critical AI studies, and our activities have focused on those objectives. As one field, one or some fields or some outcome, we have suggested 4 outcomes, which I already mentioned, so I will not mention them in detail here. But in terms of critical AI studies, we didn't talk about concrete examples, so I would like to give some concrete examples of critical AI studies. AI ethics. Critical AI studies and AI ethics are closely related. When we use the word ethics, what can you do with AI? What you should not do with AI? What's the criteria to judge good and bad? Yes, it is a criteria for good and bad, but we're not pursuing a checklist for judgment. Rather, what kind of society is this? What kind of technology is sought by the society? And we want to think deep about that kind of subject. And I think that will be one of the essential elements. So in that sense, regarding physics and brain science, you talked about research projects. And Professor Harada talked about how we pick up information, and I sympathize with that point. So what kind of subject do we focus on in order to delve deep into that subject? And what's the reason we have to do that right now? And I think critical AI studies would be a starting point to think about that. And we are talking about this as study on AI, but studies or working style or attitude to work is something that we should be thinking, not just in the context of AI. So in critical AI studies, it's an area to once again question the existing order. That's the definition, but if I may give one example, this is a frequently quoted point, but dichotomical gender type of discussion on chatbot and voice assistant and female voice is quite often used. You hear. Why is female voice used? Heteronomical dichotomy type of gender conflict may be an issue we should also raise. And another example is with the emergence of generative AI, drawings and music can be created by AI with high level of precision. Can you call that art? Or what is the definition of creativity? So those are some questions that are being asked. But is AI creative? Rather than the question of whether AI is creative, where have we found creativity so far? I think that kind of new question will be asked. You can use AI for this. You can't use AI for that. That kind of value judgment is important, but in critical AI studies, it's not the guardian of technology or watchdog of technology. This is an academic field to once again question those points. Thank you.
Thank you very much. Actually, I wanted to ask you exactly that question. Thank you very much for responding in advance. Lastly, mid to long-term research leaders, regarding beyond AI, could you give us one final comment before we conclude this panel discussion? May I? I was thinking about the order of speech from this way. So, so, so I thought you were looking at me. So I just wanted to ask everybody to say final comment. So let me, in relation to the last question as well, the role of physics is actually similar to the question raised. The dangerous thing about AI is that AI will go along with what only AI can understand. For example, in order to prove the theorem of mathematics, AI would come up with 1 million pages of substantiation. What does it happen to human? 1 million pages. Human beings do not understand all these pages. Therefore, the human would not understand what is that question and what is the right answer. Therefore, if we leave everything up to AI, things would go ahead in this way. Therefore, as simple as possible. That is because humans can understand. Humans can understand only simple and concise things. Therefore, for AI, what is at the core, what is essence, that doesn't matter. However, from the physical perspective, we have to go hand in hand with humans and AI.
と言いましたけど、
Thank you. I said regarding beyond AI, but you can freely speak on anything. So, closing comments from each of you. Professor Tabata and Professor Harada asked to speak at the end. We talked about the keyword yuragi, which is the physical phenomenon, and stochastic resonance was explained. And Langevin equation is a simple equation that explains that. The most simple Langevin equation does not include the function of memory. So Markov type of assumption, case by case. But generalized Langevin equation is there. And then in that equation, there's the memory function. So it's closer to human beings. So there is transformation and expansion in physics and adjustment. So in such a way, we're talking about beyond AI. So as something that comprehensively covers AI, we hope that we can contribute to the development of AI. And in the first half, Professor Ohki asked a question on where's the border of yuragi. It's noise if you think about it technically, but at the same time, in our daily lives, there could be ambiguity, you could be waving, and some human aspect of mental fluctuation also exists. And that cannot be expressed explicitly in words physically. So that's, I wouldn't say Japanese, but something new may come about, which is comprehensive. So by doing research on yuragi, I am fluctuating every day.
まず、
First of all, for the past 6 years, I was able to engage in mid to long-term research. Thank you for that. And listening to other people's speak, I understand everybody's making progress, centering around AI as a common theme, the social science and brain science and physics. So this is interdisciplinary research, and I am grateful for the environment which we have been given. And we should not lose this momentum going forward for the next 4 years. I want to make progress in this area.
本当に私も
I'm so appreciative of Beyond AI. And as I participated, I began to think about what intellect is about. Brain creates intelligence, and AI creates intelligence. And what I have been thinking is about life, is reducing material entropy locally. And if intellect is also aligned, then locally the information entropy to be reduced. So that's how I call intelligence. So based upon such definition of intelligence, AI is more intellectual than human beings. And intelligence is only one aspect of the whole. Like in the trinity of intelligence, emotion, and will, it's only one aspect. So in my area of dynamic science, maybe it's an area where I have to take a deep dive into. That was my experience through the 6 years. Thank you.
So mid to long-term research, this is going to be a conclusion, and I happen to be seated here at the time this ends. However, about a year ago, I became the leader of this research project. Before that, Professor Hayashi, Professor Idatsu have been leading the project for the 5 or 6 years. So it so happened that I succeeded at the ending point of this project. Therefore, I am grateful for the research network and foundation of research which has been built by predecessors. So I took over that and I ran for the past 1 year. So I can only thank for the efforts made by these two predecessors. I myself, I am specialized in the history of the 19th century America. Therefore, I never thought that I would be engaged in AI studies, and I never imagined that I'll be speaking on such a august occasion. If you look at modern society, contemporary society, that is very interesting, but at the same time, in various fields, AI is a problem, and also at the same time, it is an exciting field. So I am very grateful for the opportunity given to me to study. And Professor Hagiya, thank you for supporting me for the past 6 years. Thank you.
この6年間
Thank you for the wonderful 6 years. I thank SoftBank and Professor Hagiya for your contribution. When I think about AI, there's rapid evolution, and we tend to become overexcited. Now, the evolution is very rapid, but we don't have much clear foresight. But if we look deep, something that was right, 60 to 70% has become 100%. But what was originally 0% or 1% right, has that increased to 90%? No, because difficult problems continue to be difficult even today. So we will take a ride on AI. We can't miss the train, but we would like to focus on the essence. And I have seen so many research projects disappear in a year or two. And in conferences, in one conference, 20,000 or 30,000 articles are accepted just in one conference. But many of those research projects are destined to disappear. But this is an academic area, so we think what kind of research will survive for 5 years, 10 years' time. And I think that's very important, and that's what I learned in the 6 years. So I hope that we can continue to do what we ought to be doing.
Thank you very much. At the beginning, I said we may go overboard, but we extended the meeting by many minutes. So I thank everybody for attending, and also my thanks goes to panelists as well. Professor Harada, Professor Saitoh, Professor Tabata, Professor Ohki, Professor Ikegaya, Professor Hisano, and Professor Hagiya, thank you very much for very active discussion. Once again, please give a big round of applause to the panelists and moderator. With that, we conclude the second session panel discussion.